Hello and welcome. My name is Sebastian Link. I'm a professor of computer science and also the chief science officer for the company DataViadotto. Today is my distinct pleasure to take you through a demonstration of the first available entity relationship profiling tool. For that purpose, we will discuss what entity relationship profiling is, what the need is, who the beneficiaries are and what the benefits are. And we will then illustrate on a use case the process of entity relationship profiling with our tool. And at the end, we will analyze the results and the impact of those. So let's get started on entity relationship profiling first. We are in the era of data, and companies actually generate massive amounts of such data to get any insight on their company themselves or on the customers that they serve. For that, they need a model to actually be able to generate the insight. So the biggest obstacle is actually to align the data with the business functions. And therefore, we need a good fit between the data and the model. So the insight that is actually generated is always assembled from data that is about the essential business entities, for example, customers and products, and then relationships between them, for example, sales and acquisitions. So this sounds very much like entity relationship modeling. But in that approach, you're given a model and then the data is generated to support the business functions of the model. So this is going in the other direction and therefore not of immediate use. So what we want is actually entity relationship profiling, where we discover all the different ways to uniquely identify entities and relationships from the given data sources. So here we can actually establish the fundamental cornerstones how to generate a model from the data. So this is now termed entity relationship profiling. So in this sense, this is the discovery-focused, data-driven counterpart to entity relationship modeling. So the need for ER profiling arises for organizations that no longer have a choice, but to discover what stories data assets actually hold for themselves and their customers. Given a data set, one company who might be able to decide the relevance of the data for a project, who can generate insight from this data set, might have a competitive advantage over those organizations that do not. So once it has been established how relevant the data set is, the data then needs to be integrated into the existing data repository. And only if those questions can be answered effectively, data actually becomes useful, right? It's no longer a liability that you feel the need to deal with, but it actually becomes an asset and provides value and insight. So organizations therefore need to understand how they can align data and business rules. How do they interact? How is the data governed? Only if you can answer those questions, you can enable all the things that you want to do: accurate and fast reporting, analysis, and prediction. So the problem that our entity relationship profiler solves is to take any given data source, for example, in the form of CSV files, and to compute all the keys that hold on each of the given data sources. So those keys are combinations of fields that uniquely identify every record in those tables. So therefore we know how to identify business entities uniquely. But then we are also interested in the relationships between different tables. How can we connect data sources? How can we link them to generate the insight from the union of all of them? So for that purpose, we have a relationship finder as well that finds effectively all the relationships that hold between given data sources. So with these two tools, you're actually in a position to generate a data model that is a perfect fit for the data that you have. And it's only through this perfect fit that you can maximize the acquisition of value from data. So what are the general benefits of entity relationship profiling? Of course, this automates data preparation. You can save resources through that. actually massive resources because data science projects require most of the time for data preparation. But once it's automated, the process is also no longer error prone through human errors. It's therefore fast and creates accurate insight. So altogether, this facilitates all fundamental processes for data management, analytics, and science. And through the discovery of keys and foreign keys, we have actually direct use cases, for example, to effectively organize data. So keys provide pathways to critical data elements, but also points of reference for joining new or external or internal data sources with those data sources in your repository. So therefore, data silos no longer keep occurring, but you can integrate your data assets using matching fields across tables. And we can find all of those given our tool. And this can be done even though there is a lot of missing data or there are inconsistencies in the form of violations of business rules. So our tool is still able to function properly in those cases. Ultimately, we also improve data quality. Of course, we can enforce entity integrity with keys and uniqueness constraints, but also referential integrity with foreign keys. As another use case, we can find all the different IDs that have been used for the same entity. So this is known as entity resolution or entity disambiguation. We can also use the keys to impute missing data by consulting external data sources, since the keys allow us to uniquely identify business entities and then derive properties from other sources and use them for our own. Of course, foreign keys remove data redundancy and therefore sources of inconsistencies and inefficiencies in updating the database. In general, entity relationship profiling provides better performance, right? So keys, for example, or unique constraints allow us to define indexes that provide faster access to critical data elements. But we can also optimize join types and queries. For example, a right outer join could be actually implemented as an inner join. The use of business keys and foreign keys allows us to establish more trust in the data. We are no longer dependent on using internal artificial identifiers, but we can actually rely on meaningful combinations of natural fields. And this increase in data quality and data standards actually allows us to derive insight from accurate reports. Similarly, for analytics and forecasting, we are able to use higher quality data and therefore also arrive at higher quality insight. Yeah, so ensuring that we don't have violations of referential and entity integrity. Our training data can be less biased because we might not be using unconsciously the same business entities anymore and therefore overfit the model. And by the use of natural keys and foreign keys, these models also become more explainable and understandable. So it's not a surprise that all these benefits are also for your team of data professionals. So analysts, for example, can now run accurate, transparent reports. Architects can actually craft performant data models from this basis onwards. Engineers can build robust and effective data pipelines. Scientists can manage effectively feature stores similar to a database system. And stewards are in a position to assemble very comprehensive catalogs using all of these business rules and the fit with the underlying data. Let's now have a look at our showcase. For that purpose, we picked a publicly available hockey database from the URL given up there. And this includes data about ice hockey leagues, predominantly the National Hockey League, NHL, from North America, but also other leagues listed here. The data is about individuals taking part in these leagues, but also comprehensive team statistics, and has been accumulated over more than 100 seasons. The data comprises 22 tables, approximately 100,000 rows and 300 columns altogether, and it takes up 15.6 megabyte. So this is a database and data model that have been publicly available for some time, and they both have been curated for decades as well. Nevertheless, there are fundamental problems with entity and referential integrity. Most of them unknown, but some of them are. In particular, 9 of the 22 tables have no primary key defined on them. And the referential constraints are quite flat, so there are no chains of foreign keys, which also illustrates opportunities to improve the model itself. So what we will do, we will apply our entity relationship profiling tool to re-engineer the actual schema. So we will be in a position to rediscover all the keys and foreign keys that actually have been specified on the schema. We will be able to do this just from the given data, but more so, we will also be able to find additional keys, uniqueness constraints, and foreign keys that lead to a better model. Along the way, we will also discover data quality problems and a misalignment of the data with the model. So we will now start with our demonstration of the tool. Welcome to the DataViadotto Entity Relationship Profiler. The first step is always to connect to your data source. You can see we haven't added any connections in here, so let's just do that right now. We are picking a MySQL database repository. We can choose a particular name. In our case, hockey. We have guest credentials. The server name is already here. And the port number is correct. We then connect. So all the database schemata available are actually retrieved. We can then pick the ones that we're interested in our case, the hockey one. So we just click on sample here. Then we fetch all the different tables that belong to this particular database. In our case, that will be 22. And then we can sample as a second step. So sampling essentially enables us to make key and foreign key discovery scalable. In our case, the database is small enough that we don't have to eliminate any records. So the samples will actually coincide with the actual table. So discovery will be exact. The sampling here is already completed in 15 seconds. And then they become accessible in the Sample Explorer. So here you can see the different tables, and there's some metadata attached with them. So if we click, for example, here on the teams versus teams table, we can see the different field names, a null count for each of them, a distinct count, and a row count. If you don't want to connect to a database, but you want to just connect to a file like a CSV file, you can also do that here. And you can choose some parameters and then sample that one. So that's really the first step, connect and sample. So once we have our samples available, we can then find keys and foreign keys. And we recommend to do this first by finding keys and then perhaps using those keys to mine relationships, but you can also choose to find relationships directly. So let's just find keys first. So we click then here on find keys. We need to select our samples. So what tables do we actually want to mine? In this case, we want to mine all of them, right? So all 22 tables, we want to find all the keys available. And you can put in here the maximum number of fields that a key you're interested in should consist of. So here we pick as default value 3. You can change that, and that impacts the time and the result, of course. There are different advanced settings in here as well, like setting a completeness threshold. But we leave that out for now. We just click on finding keys and checking how quickly it finds it. And in fact, in 3 seconds, it finds 127 different keys. You could then continue with finding relationships. And here we choose only to mine foreign keys as a default setting. Again, there are different parameters that you can pick that influence the results. Here we're only interested in exact foreign keys. You can lower the inclusion threshold then to accommodate dirty data as well. And there are even more parameters available under advanced settings. But here, what we want to find is we want to find relationships between all pairs of tables in our hockey database. So we just select all of them, and now we actually mine all of them, all relationships in all pairs of these tables. So we click here on find relationships and then see how long that takes us. Should last about 25 seconds perhaps. And here we haven't restricted the foreign keys to reference keys now that we've previously mined. No, we actually have made this restriction. So we're mining all possibilities in here. And it returns actually 47 relationships, right? So if we wanted to use our previous results on keys, we can pick those keys that we've previously mined and then restrict the search to those foreign keys that reference only these keys. We can then see what happens, how quickly you can find these relationships. And there are only 29 relationships, and they are mined within just 1 second. So big difference in here. That's why we recommend to first, profile your entities by finding all the keys, and then perhaps use those to find all the relationships. But these processes can also be done independently. We can then continue with the next step, which is exciting because we can now browse the keys and the relationships that we try to find. So we click on the browser, and that brings up all the mined keys that our algorithms retrieved. You can then inspect the different tables. So for example, the combination of award and year on the awards coaches table uniquely identifies all the records in that table. And you can browse these through. So for this example here, we're interested in playoffs. For example, here in Series Post, we have here different combinations that are key. So for example, the combination of year, the winning team and the losing team uniquely identifies every series in a playoff. And we can then check and engage with the underlying data to actually see whether this is sort of a meaningful key or not. You can see here that also the combination of year, winner, and loser is minimal to identify all records. If you omit an attribute like year, you get duplicate values because we can have the same winning and losing team in different years. And similarly for the other combination. So there are also duplicates over just the combination of year and team ID, or just the combination of the year and the team ID loser, right? So here in the third and the fourth record, for example. So this is a minimal key, and you can pretty much think about this briefly, and it turns out it's a very sensible key, and that hasn't been discovered on the original schema. So this is sort of conclusions you can make after inspecting the actual data. You may also want to view the subsets and see with which degree they actually are unique. And you can see here that just the combination of year and team ID winner is just unique for 28% of the records, and worse for other combinations. So this is a nice way of figuring out which of the mine keys are actually sensible. And then after that, after you've selected all the ones that are sensible, you can download those and then use them for further restriction of finding meaningful relationships, actually. So if we click on browsing the relationships now, you can see now the foreign keys that we've mined from before, from the source to the target table, and the corresponding column sequences are displayed next to each other. And then we have the various thresholds that we've set and the exact values by which this particular relationship holds. At the end, we also indicate the best available join type to join these two tables. So in this case, it's a right outer join for many-to-one relationship because we are referencing a key in here. So again, as before, you can now scroll through these results and see which ones are sensible, which you want to enforce. Let's perhaps go to the series post table that we've analyzed before. So this is referencing, for example, the teams table via the year team ID loser attributes that reference the year and the team ID in the teams table. And again, you could inspect sample data for that, like this one in here. And the other relationship from the teams table to the series post table is not valid, right? So all the raid records in here violate this relationship simply because not every team, of course, makes the playoff, right? So this is sensible in here, but you can directly verify this again using the data samples in here. So this maybe gives you a good indication of the tool and how it actually helps you to identify meaningful relationships from the ones that were mined. So we may also be interested in just validating to which degree a particular key or relationship holds. And for that purpose, we don't have to mine all the tables, but we can simply click on a validator. And then you can select a source data sample and a target data sample if we want to validate a relationship. So in here, we might be wondering, okay, so we have a playoff series, so on a series post, but we also have the teams that actually made the playoffs for each of the individual years. So clearly there should also be a relationship between those. So let's pick a target table, the teams post table, and then check what relationships might be sensible in there, right? So for example, that the year in here and the team ID winner, that combination should actually reference the year and the team ID, right? So that makes perfect sense. Each winning team of a series should actually be a team in the playoffs, right? So we could validate that relationship, and we could actually see, well, it's surprisingly it only holds for 99% of the tuples, right? So, and this is actually a violation of referential integrity. So clearly this is a sensible relationship in here. Every winning team in every year should also be a team that made the post season, so playoffs. But here this is violated, right? So it's not true for all the tuples, and we can see we can inspect this relationship, and we can see here records that validate this relationship, right? For which it holds. So here 2000 PIT is actually listed as a team in that year. But then here for older records, this is no longer true, right? So 1914 VML is displayed in red because it's not listed as a team in that year that made the playoffs. And this is a clear violation of referential integrity, and actually occurred because this was not an enforced foreign key on the database, which is very much surprising. And this actually showcases that things might be completely indifferent to what is sensible and what you should be doing or what is expected, actually. So this is an interesting case. And moreover, right, so you can see now it only holds with 99%. So previously we couldn't find this because we only mined exact keys that hold for 100% of the records. But of course, you can also change that. So if you go back to the finder and now you lower the inclusion threshold, right? So let's say we go down here to 90% in here, perhaps similar for this threshold. And then we could perhaps mine again, right? So after we choose again our samples. So let's pick perhaps just the two tables because for the purpose of this example we're just interested in them. So we do series post and the teams post because we're just interested in relationships between these two tables. Save that, and then that will save us time as well. And then we click on find relationships, and in fact it finds 7 relationships just in 1 second. And now we can browse and we can actually see it finds not only this one but several others, namely also the same um, you know key in the post table should be referenced by the year and the losing team, of course. And again, we have referential integrity violations, um, and so on. So you can clearly see the benefit of lowering the thresholds if you have dirty data, right? So and this is again by viewing the data in here from the samples. It's a nice interaction between understanding the data and the relationships that your data is governed by. So this is then the actual real value of the tool to help you find those relationships, those entity and um, relationship constraints that your data should be really governed by, and therefore you get more understanding of the data and how it should be organized. We will now analyze the results of the entity relationship profiling process. So there were 13 primary keys given on the original schema. All of these hold with 100% uniqueness and completeness, and we were able to rediscover all of them using our tool. For the existing relationships, there were 27 foreign keys on the original schema. Our profiling process also revealed several measures that are listed here in the table. It turns out that the last rule, where the master table references the coaches table, is incorrectly specified. The coaches table should instead reference the master table, as it is the case with other tables. More excitingly, our process revealed additional keys and relationships that should sensibly hold on the database. Some of them do, others don't, as we have seen. In particular for the tables in black font here, which didn't have a primary key specified on the original schema, we have listed several sensible uniqueness constraints and candidate keys that should be specified on the schema to improve entity integrity and the data quality altogether. This is also the case for the new relationships that we've listed in here. The example that we've seen during the demonstration is part of this, but there are several others listed as well. Again, these include also the best available join types for them based on the current data that we have. Altogether, this leads to an improved data model that you can see here. So you can see here in black font and magenta font 3 foreign keys, 2 from the series post table to the teams table, 1 from the teams post table to the teams table. In addition, we've now revealed the 2 orange foreign keys from the series post to the teams post table. And by revealing those 2 orange foreign keys together with a black foreign key, the 2 foreign keys in magenta have become redundant because they're already enforced by the other 3. So altogether, this makes a very strong use case that's representative of entity relationship profiling. Again, the data professionals have a lot of benefits resulting from these. The data stewards, for example, have a beautiful summary of the data and the links between them. Architects actually have a blueprint for aligning data and models, and are now able to derive high quality models for other projects from this one. Engineers have new business rules that they can monitor and enforce. They have new unique indexes available, as well as join types to speed up data processing and make data pipelines more effective. They're also in a position to reduce inconsistency and incompleteness that we've revealed by our processes. And this all puts analysts and scientists in a much better position. They can access data more effectively, write reports with higher quality, and predict as well better and faster. And it also adds transparencies through the use of business keys and natural foreign keys. So altogether, a very comprehensive use case, and it's representative of what entity relationship profiling with our tool can achieve. So we hope you enjoyed this presentation. We do think we are the best in finding keys and relationships for any kind of table. So get in touch with us if you want to use our tool, and we are looking forward to be part of your success story. Thank you very much.